Hello. Today we're going to talk about a topic that is of keen interest to a number of chip makers recently, and that is external sensor integration and how to unify that data easily with data from other sources to do advanced process analysis. Now, there are a lot of reasons somebody may want to integrate an external sensor with a piece of equipment, and this advanced wafer fabs have done this for many years. The challenge has always been how to use that data conveniently along with the other data sources without a lot of custom transformation and integration software. The good news is that the EDA suite of standards allows us to do that very conveniently by dealing with all those data synchronization and alignment issues close to the source rather than after the fact. And so I'll be talking about how that can be done. These are excerpts of a presentation that was made at a conference at Semicon Taiwan in September 2015, and there'll be a lot more information in that presentation if you'd like to see it. So in any sensor integration project, the first challenge, of course, is finding a sensor that actually works, something that senses the phenomenon that you're looking for in a way that's useful. But that's really the first step of the process. First of all, many of the processes have dangerous and harmful chemicals that could destroy a sensor if sampled at the wrong time. And so it's important to know when to actually activate a sensor, especially if you're actively sampling something from the process. Once you've done that, of course, you have to make sure that the timestamp of the data that you're sensing is aligned and consistent with the data from the process tool, because if you have a shift in that data, then you will end up with invalid or erroneous results. Of course, the other issue is that the binary representation of the data that you've sampled may be different than that comes from the equipment or other sources, so you may need to do units conversion and scaling to put those in the same engineering units. Next step, of course, is most analysis applications don't want to know that the data came from different sources, and so you would need to apply the factory naming conventions in the same way to both sets of data so that the analysis applications would not have to understand the different data sources. Of course, another important piece of synchronization is knowing exactly which process chamber, which substrate, which recipe step was active at the time the data was sampled, because all of this context information is necessary to line up the sensor data with the equipment data collected at the same time and under the same conditions. And then finally, depending on the nature of your analysis applications, in order to have statistical validity of that data, you may have to resample the sensor data on the same basis as the equipment data, or vice versa, to make sure the analysis applications work. So here's sort of 7 different sort of challenge areas in taking external sensor data and using it effectively. Now, you can see from the picture here that a typical sensor integration approach with an external box that has its own sort of architecture to do that in the context of a factory system, those 7 challenge areas are scattered all over the architecture, and it can be a real mess trying to actually make all that work together. By contrast, what we've called the sensor data fusion architecture, which leverages the EDA standards and platforms, handles a lot of those 7 challenge areas very close to the source and in a very natural way. And just looking at the model, this is a very big piece of it, the equipment model that holds all that data. So on the left side of this picture, you can see that the equipment structure is represented, and the process chamber in which those internal sensors appears is shown. On the right side, you have a much smaller model, a skeletal model, that has identical structure, but the external sensors appear in the same logical position as the internal sensors. And so the data that will result will have the same sort of naming convention. Likewise, to handle the context information, the process tool itself may have a very rich context vector for all the pieces required there, but a subset of that would be required to actually align the sensor data with the equipment data later on. And so you can see the two, compare the two models there for the internal sensors and the external sensor. So if you look at the 7 challenge areas and where they are handled in the sensor fusion architecture, you can see that most of them are handled right there in the sensor integration architecture very directly and naturally by the EDA technology, with only a couple of them external to that part. So the data fusion, if you will, happens very close to the source and makes the integration problems much, much simpler. So for more information, feel free to click on the link at the end of the text here, and you can find the entire presentation of which this was a part. Thank you.